about another type of Spark transformations, set operations. RDDs support many of the operations of mathematical sets. Some set operations are performed on a single RDD. The most popular ones are sample and distinct operations. The sample operation will create a random sample from an RDD. It is quite useful for testing purpose. Sometimes we want to take a little random sample of larger datasets to apply some transformations, and we want to do it on our laptop. This is when the sample operation comes in handy.
The sample method takes 3 arguments. The first one is whether the sampling is done with replacement or not. Sampling with replacement is a way of doing sampling. It's more of a statistical term rather than a Spark concept. I reposted an article which explains what is sampling with replacement. If you're interested in learning more about it, take a look at the next lecture. The second one is the sample size as a fraction. Let's say we want to take 1/10 of the original dataset. We can just put 0.1 as the sample size. The third argument is the seed, used for generating random numbers.
Next, we'll talk about the distinct operation. The set property which is often missing from the RDDs is the uniqueness of elements, as our RDDs often have duplicates. The distinct transformation would just return the distinct rows from the input RDD. Keep in mind that the distinct operation is quite expensive because it requires shuffling all the data across partitions to ensure that we receive only one copy of each element. You should avoid using distinct operation if deduplication is not necessary for your Spark workflow. There are some set operations which are performed on 2 RDDs and produce a resulting RDD from those 2 RDDs. Some popular ones are union, intersection, subtract, and Cartesian products. It's important to note that all of these operations require that the RDDs being operated on are of the same type. Let's start by introducing the union operation. Union operation gives us back an RDD consisting of the data from both input RDDs. This is quite useful in a lot of use cases. For instance, we can use it to aggregate log files from multiple sources. It is worth mentioning that unlike the mathematical union operation, if there are any duplicates in the input RDDs, the resulting RDD of Spark's union operation will contain duplicates as well. The next operation we'll talk about is intersection, which returns the common elements which appear in both input RDDs. Intersection will also remove all duplicates, including the duplicates from single RDD, before returning the results. Keep in mind that the intersection operation is quite expensive since it requires shuffling all the data across partitions to identify common elements. The next one is subtract. The subtract function takes in another RDD as an argument and returns us an RDD that only contains element present in the first RDD and not the second RDD. This is useful if you want to remove some elements from an existing RDD. Similar to intersection and distinct operations, subtract operation requires a shuffling of all the data, which could be quite expensive for large datasets. The last operation we want to talk about is Cartesian. The Cartesian transformation returns all possible pairs of A and B, where A is in the source RDD and B is in the other RDD. The Cartesian product can be very handy if you want to compare the similarity between all possible pairs. For example, we can compute every user's rating in each movie. We could also take the Cartesian product of an RDD with itself, which would be useful if we would like to analyze things like product similarity. Now, let's take a look at a real-life example. Here we have 2 tab-separated proxy logs files from one of the NASA's Apache servers. The proxy log file contains the host name, log name, time, the HTTP method, the URL, response code, and the number of bytes. We have 2 log files. One contains 10,000 log lines collected on July 1st, 1995. The other one contains 10,000 log files collected on August 1st, 1995. Let's open the union log problem file under the rdd.nasa Apache weblogs package. The task is to create a new RDD which contains the log lines from both July 1st and August 1st, and take a 0.1 sample of those log lines and save it to sample NASA logs file in the out directory. Make sure the header lines are removed from the resulting RDD. Let's see how we resolve this problem. Open the union log solution file under the same package. First, we create the SparkConf object. In this program, we specify localstar as the master URL, which basically means our Spark application will run all the available cores on our local CPU. Then we create a Spark context project from the SparkConf we created. Next, we load those two input log files as two string RDDs. Then we call the union method on the July 1st log RDD and supply the August 1st log RDD as an argument. This will give us back an aggregate RDD that contains items from both RDDs. Then we filter out the header lines. We have extracted the filtering logic to a separate method called isNotHeader. We get back a clean log file RDD which doesn't contain the header lines. Then let's take a sample of 0.1 on the RDD. Lastly, save the resulting RDD as a text file. Let's run this application.
To run this application, just use the Spark submit command that we saw in the previous lectures. Open a terminal and type Spark submit and the path to our file.
After the execution is done, we check out the output file from the out directory. As you see, we have 4 output files. It means our Spark application runs on 4 worker threads. Each output file contains a portion of the aggregated log files. Now, we're done with the Spark program, which demos how we use the union operation to consolidate logs from different time. It's time for you to do a practice. Let's open the same host's problem file. We'll still be working on those 2 log files. Your task is to create a Spark program to generate a new RDD which contains the hosts which are accessed on both July 1st and August 1st. So the resulting RDD will only contain the same hosts, not the full log line.